So I want to talk a little bit about standard form of a parabola. All right, so this is standard form of a parabola. So f of x, just a fancy way of saying y, is equivalent to a x squared plus b x plus c. And so you'll see an a b, and a c. And these are really important parts and can help us into identifying a lot of things with a parabola. Let's start with what C tells us. Okay, C actually tells us the y-intercept of the parabola. So if I had 5x squared plus 2x plus 7, my parabola would have a y-intercept of 1, 2, 3, 4, 5, 6, 7 up here. Okay, because C is always going to be the y-intercept. Okay, and the y is on the y-axis. And also, just to note, the point here is 0, 7. If I had one that said 2x squared plus 4x plus 4, okay, then my y-intercept would be over here at a positive 1, 2, 3, 4, and my coordinate here would be 0, 4. So as you can see, no matter where we are on the y-axis, the y-intercept always has an x-coordinate of 0 because we're not moving left or right. We're still near the origin. We just went up a certain amount of units or down depending on what our y-intercept is. So that's what C tells us about our parabola. Now, A and B can be used to help us to find the axis of symmetry and then also to help us find out what the vertex is. Okay, so X, which is our axis of symmetry, is equivalent to negative B over 2A. Okay, this is going to help us to find our axis of symmetry. Let me give you an example. If I told you that f of x was equal to 2x minus, let's say 4, 2x squared minus 4x plus 1. Well, I know that my y-intercept is 1, but now let's see how the b and the a help us to find the axis of symmetry. Well, my b here is negative 4. My a here is a positive 2. So if I substitute that into the equation, my b is a negative 4. My a value is 2. See how I just replaced the b and the a with the negative 4 and the positive 2? Well, negative 4 is a positive 4, and 2 times 2 is 4. So my axis of symmetry, is at x equals, 4 over 4 just reduces to 1. So let's say I was going to graph this one. Okay, my axis of symmetry is at x equals 1. So it's somewhere, or this is the axis of symmetry, at x equals 1. Now the vertex lies on that axis of symmetry. Okay, if you recall, a vertex is the turning point. So anywhere on the left or right is going to be symmetrical. Therefore, the x value that we just found is part of the vertex. So if I wanted to find my actual vertex, well, I already know that my x is going to be at 1. So I'm just going to evaluate it when when x is 1. So I'm going to, instead of doing an x squared, I'm going to do a 1 squared. Minus 4 times 1 instead of x plus 1. So that's 2 times 1, which is 2, minus 4 plus 1. 2 minus 4 is negative 2 plus 1 is a negative 1. So that tells me, just write some of these. Okay, that tells me that if I go in the x direction 1, then I must go negative 1 in the y direction to get my axis of symmetry, my vertex. So my vertex is right over here. It's on the axis of symmetry. Okay, the x value is the x value of the axis of symmetry, but the y value is determined by evaluating at that x value.